Potentiometer. A potentiometer, as the name suggests, is an instrument used to measure an unknown potential difference. A potentiometer has four 1 meter long wires stretched parallel to each other on a broad wooden board by the side of a meter scale. This wire is generally made of eureka or manganine and is stretched along a wooden board with its ends fixed to thick copper strips. The end A reads 0 centimeter and the length of the wire between A and B is 400 centimeters. The wire is connected to a source of constant EMF through a rheostat, an ammeter and a one-way key K. A galvanometer is connected between the end A of the wire and the jockey or slider S. Principle: when a current flows through a wire of uniform thickness and same composition, potential difference between its 2 points is directly proportional to the length of the wire between the 2 points. V is directly proportional to L, or V is equal to KL, where K is the constant of proportionality called the potential gradient. A potentiometer works on this principle. If we plot a graph between V and L, a straight line graph is obtained. Comparison of EMF of two cells. A potentiometer can be used to compare the EMFs of two cells. For comparing the EMFs of two cells, arrange the cell as shown. The EMF of the driving battery is constant and more than that of given experimental cells E1 and E2. The positive terminal of the cells E1 and E2 are connected to the zero end terminal A of the potentiometer, whereas the negative terminals are connected through a two-way key to a galvanometer and a jockey. The measurement of EMFs is carried out in 2 steps. Close the main key K and the key K1 so that the cell E1 comes into circuit. The jockey is moved gently along the potentiometer wire AB till a point is obtained where the galvanometer shows no deflection. Let this point J be at a distance L1 from the zero end. At this point, E1 is directly proportional to the length of the balancing wire. E1 is equal to K into L1, where K is the constant of proportionality. Click on the keys K and K1 to open the circuit. Now close the main key K and the key K2 so that the cell E2 comes into circuit. The jockey is again moved along the potentiometer to find the balancing point. Let this point be at a distance L2 from the zero end. At this point, E2 is directly proportional to the length of the balancing wire. E2 is equal to KL2. The EMFs are compared by dividing the two equations. E1 is equal to KL1 and E2 is equal to KL2. That is, E1 by E2 is equal to L1 by L2. If one of the cells is a standard cell, the EMF of the other cell can be found accurately.